I think it's time. So I'm going to start my presentation about MADlib. So I'm Hitoshi Harada. Thanks for coming today. First of all, I'm going to talk about myself. I introduce myself. I initially started to work on Postgres as just a hacker, and I wrote a window function patch in 8.4 and extended it in 9.0. And also in 9.1 development cycle, I helped writable CT feature with David Feta here, and I'm not sure if Marco is here or not, but it's a great feature. And I'm now working on PLV8. Thanks, Peter. I really appreciate about the advertisement around the John, Peter, hello guys. This is a cool feature, but actually I'm not talking about PLV8 today. And I'm also working on other modules like Twitter FTW, tinyint, which is a 1-byte integer extension. And I joined Greenplum last year. I really enjoyed the development life in Greenplum. So I just want to ask you, how many people here have ever heard about Greenplum? Oh, awesome. Great. So a lot of people may know about Greenplum, but I just talk about the architecture of the Greenplum. So Greenplum is a company that develops a Greenplum database, which is forked from Postgres 8.2, and it's a distributed database system. So in this is the typical cluster system of Greenplum. Greenplum is so here's a master server, and the cluster has a whole bunch of segment servers, and the query is dispatched from master to a segment, and data is distributed in segments. So the query processing is parallelized in the segment server. So a lot of customers have experienced like terabyte of data or petabyte data, and they process the huge amount of data in Greenplum. So let me explain about what's going on in Greenplum. So I think you guys are a little tired about big data, but I think a lot of people are talking about big data, but not only us, but also the media companies like CNN or blog people around here. So we think the big data, true big data era is here. So here's a simple example about our typical customer. It's just an example, but it explains what we are doing. So in the legacy system, in the enterprise system, the customer couldn't do any report because the big data is too huge and the legacy system is too slow. So they tried to run the reporting query, but it took days or sometimes weeks. And then Greenplum is the massive power processing system. So actually the Greenplum, they bought a Greenplum database, and the system can run the query and run the query in a few seconds for the big chunk of data. So they started to understand the fact data, what's going on behind the data. And after that, the customer started to predict their future, or they're trying to optimize their profit based on data. So after understanding a simple fact behind the data, they are trying to leverage their data to optimize their profit. And for example, this customer is trying to do user-based recommendation based on the data. So they need to aggregate and more so leverage their data. And the problems we are facing is kind of this. So this is a very simplified traditional BI analytics workload. On the left-hand side, this is a database which may be a Postgres or Greenplum, and the analysts use analytics tools like you may heard about SAS or R, or maybe some kind of BI tools, and they needed to extract the data out of database to put it to the analytic tools and run the analyze, then get the result back to the database to understand to do analytics. Now today, a database gets bigger, and also the companies are collecting all kinds of data, not only the enterprise system, but also they are gathering the data from the Facebook, Twitter, or Office applications. So the problem here is those softwares like the analytics tools are not designed for this kind of big data. So basically, those kinds of software are in-memory system, and it is hard to make it parallelized. So performing the analysis is a bit a challenge, and so they needed to extract the data out of database, but it is impossible to do analyze on the entire data set. So they needed to sample. They needed to extract a small subset of the data and to put it into the analytics tools. But this doesn't solve the problem. So we are trying to push the analytics calculation into a database. This is exactly what we want to do. The main concept here is R3, magnetic, agile, deep. Magnetic means, so the database is now like a magnet. They're collecting all kinds of data, not only structured data, but also this unstructured data. They're using the data source from SNS. And agile, I think the nature of analytics is kind of iteration, and we need to do some try and error and get some insights and get feedback to the line of business, and they try the hypothetical analysis based on the insight that they got. Also the deep. I think the standard SQL defines some kind of analytics features, like simple aggregate function, window functions. Also, there are grouping sets, drill down, analyze features, but it's not enough. We do need more accurate method, more deep statistic method, like linear regressions or more complicated methods. So here comes MADlib. So we are developing a MADlib. So first of all, we introduced this new usage of database, enterprise data warehouse, in 2009 in VRDB. A colleague from Greenplum and also the Joe Sane from University of California, Berkeley put together this idea into one paper and introduced a MAD scale, new analysis practices for big data, which describe things that I explain now. And we started the MADlib project as a software development, and we reported this status in this year. just a few months ago. The MADlib, how the MADlib project is now. So MADlib, the definition, why we call this MADlib. MADlib, MAD stands for magnetic, agile, and deep, which I explain now. Lib stands for, of course, library. So MADlib is an add-on to the Postgres or Greenplum. So this is just a library, and you can install to your database, and you can run the analytics methods. MADlib has advanced methods like mathematical, statistical, machine learning modules, and it is actually designed for power and scalable because Greenplum database is a power database, and you can scale out for the big data. And all the interfaces for the analytics method are defined as an in-database function, so it's just a SQL function. And the mission is to foster widespread development of scalable analytics skills. We want to harness efforts from a commercial practice from like us, and also as well as academic research from universities, and we want to do this as an open source project because we want to have more and more contribution from academic side. And yes.
What license is it available under?
This is a BSD license, and of course you can hack this project and you can send a pull request. So this is a kind of collaborative project between Greenplum and the universities, but this is a very neutral position, so it is not necessarily a Greenplum project, so everybody can contribute to this source code. Actually, currently, we have a contribution from University of California, Berkeley, Wisconsin-Madison, and Florida. And because Greenplum code base shares a lot of Postgres interfaces, so MADlib currently supports both of Postgres and Greenplum, and the version is from 8.4 to 9.1, and the Greenplum is 4.0 to 4.2. And this is designed for data scientists to provide more scalable, robust analytics capabilities. You can look at the information on madlib.net, and the source code is hosted in GitHub, so you can just clone into your desktop. And if you have any questions on MADlib or usage, just feel free to post Google groups. So MADlib is the same answer. We think the MADlib is the same answer to big data because MADlib is designed for better performance and scalability. MADlib is running inside your database, so you don't need to extract any data from that database. It's just run inside the database. And it's only for Greenplum, but leverage the parallelism. And it's very easy to use because it's just a SQL function. So you don't need no additional tools. SQL is your friend. And also, this is open source, so you can just hack the source code. I mean, the nature of this kind of analytics is very complicated, and sometimes you want to customize the modules. So predefined package may not be enough for you, but you can just read the source code, and you can just change some parameters or the module. So you can just replace some parts of the modules. Of course, it's free. I mean, yes?
Is there some process whereby we could make changes and push them back upstream?
Yes, so this is a typical GitHub process, so you can just send a pull request, yes. Actually, a lot of, you have a question? Yes?
Any idea how difficult it would be to hack it to get it working on Netezza?
In Netezza?
Yeah.
I'm not sure about the Netezza's interface, but I think the some ideas are still shared among the Netezza and Postgres. So
Yeah, it's running Postgres 7.7.
right, right. I'm not sure about the current status of the inside of Netezza, but yeah, we appreciate the contribution if you are familiar with that. Actually, some database vendors like us are providing similar thing to the predictive analytics modules, but they are proprietary software, and you cannot look at the inside. And typically, it's so expensive, but MADlib is free. So current status of the MADlib roadmap. From inside Greenplum development, we are targeting the every release for every quarter. So we've just released video 3. The project itself is a little still the startup phase, but still you can use the whole bunch of like the modules like this. So linear regression, logistic regression, k-means clustering, decision trees, and we are going to release a new version 0.4 in the end of this quarter with distribution functions and random forest. Okay, so let's go inside the MADlib architecture. MADlib has a lot of parts. Actually, on the top, we have Python UDF, so it depends on the pure Python. So you need to install pure Python first. But the pure Python controls the loop algorithm or external libraries. Like some algorithm, like clustering, need to do a convergence calculation. So it's not easy to run this type of algorithm on the SQL. So we use a Python. Also, and for the simplest way of like a linear regression, we use just a SQL function, UDF or UDA, user-defined aggregate. And we have below that we have a C++ abstraction layer. So the main concept of MADlib is not only for Postgres and Greenplum. So we have the abstraction layer in the C++, and if someone is familiar with other databases like Netezza, then you can just adapt the connector to this abstraction layer. And the database RDBMS backend has a core modules. We have some compressive vector representation as a user-defined type. And also we have just a connector like a create function interface. The whole contents looks like this. So MADlib consists of some kind of data modeling and descriptive statistics support modules. So as a machine learning methods, we have supervised learning, which are like a linear regression, logistic regression, naive-based classification, decision tree, SVM. And for the unsupervised learning, we have association rules, k-means clustering, SPD. Also, we have a descriptive statistics and the support modules like array extension. So we have the sparse vector on the right-hand side. Sparse vector is a user-defined type which compresses the typical sparse vector. So you have the very efficient sparse vector in your database. And we also extend the Postgres array type, so you can just like a summation on the array. So we just define the additional array function in MADlib. The good parts in MADlib is we have a good amount of documentation online. So you can just go to doc.madlib.net And the documentation of MADlib is good because it's not only about how to use, how to call the API, but also we have the whole bunch of the mathematic background, logic, the theory. So you can just go around here and understand the kind of idea and use it. Okay. So MADlib is, I'm going to MADlib use cases. So what can you do actually? I'm going to talk about two types of machine learning here: supervised learning, and unsupervised learning. So I think people around here may know about the differences between two, but I explain the two types of learning. So unsupervised is learning from raw data, which means you don't need any label on data. It's just you categorize the data that exists in your database. And in contrast to unsupervised, supervised learning is if you have any historical data which are labeled, then you just like predictive. You can just build predictive model from the historical data, and with that with that model you just build, you predict the new observation. You can label the new data with that model. So typical example is for unsupervised learning is a consumer market segmentation study, which I'm going to talk about. The method is k-means clustering, and for supervised learning, classify the email as a spam or non-spam. So typical application is spam filter, and there are a lot of implementation for the spam, but we use logistic regression on live base. If the label is not a yes or no, then we can use a decision tree for the multi-label problem. Okay, so market segmentation. This is very easy to understand, I think. So customer segmentation study. If you have some kind of customer database, then you can just run the k-means cluster, and then the data is automatically categorized like this. So you can see the red group as the high brand loyal group. The typical customer is age 34 and above. They tend to shop at Nordstrom. And in contrast to that, the green group is a group for the customers who are a price-sensitive group and the budget conscious. They tend to shop at Costco, not Nordstrom. Okay, so how to do that? So we have a k-means clustering module in MADlib. And after you install MADlib in your database, prepare your data. So here we have the input points, which consists of the customer data and the customer ID and some kind of attribute. Here we use just a simplified example. But so k-mean function needs to represent the attributes as a vector, not a column. So you need, first of all, you need to transform your attribute column to an array here. So just select array xy as a float array, and then save it. And then the table will look like this. And k-mean, so k-means is a traditional way to cluster your data. So there are a bunch of initialization approaches which may impact your analytics quality. So you need to choose one of the initialization approach. So k-means is just like a convergence calculation, and the k-means do some loop algorithm. So just calculate the distance from centroid, the center of the cluster from each data point. Then just adjust the cluster position until the result is stable. So actually, the initialization point is very important stuff for the good quality result. This is a kind of the try and error stuff, and you can just customize the method in the k-means cluster. Some of it is very simple to choose one of the data point as a initialization point, which is a random, k-means random. And k-means purpose is a little improved method to do that, but the cost to initialize is a little higher than random. And you can just give the centroid set as a data set in an arbitrary set. And also, depending on your problem, you can choose one of the distance metrics. So for the like GIS application, you can just L2 norm the Euclidean distance. So for the spatial data, I think the L2 norm is enough. But for the thousands of this dimensional vectors or the documentation clustering problem, you need to choose cosine or Tanimoto Jaccard index. And for the upcoming release, we make it pluggable, so you can just write your customized distance metrics function and put this into the k-means method. And then now you can run the k-means function. Select star from MADlib.k-means++. Actually, it is a little hard to read, but this is just a function, and the input is like a table name, the column name of the ID or attribute, and then which distance metrics you choose, and so maximum number of iteration, the convergence parameter, above us or not, then do it. And then you got the results. So for this example, the output points is so these two columns are the input column, and the third column CID is the result of which categorized the point belongs to as a result. And then each centroid represented in another table, so you can just look up the output here. That's the unsupervised learning for the k-means cluster. Now is how to attack supervised learning, and the use case is how to attack risk analytics. So classification analysis is, as I explained earlier, the classification is identify which category a new observation belongs to with known observations. So typically the classification process is split to two parts, one which is training, one which is the classification. Training is to build your model based on your labeled data. And the classification process is with this model you built, classify the new observation. And the example method are logistic regression. For the merge classification process, we have decision trees. Also, you can use naive Bayes. So here, I'm explaining about logistic regression for heart attack prediction. Calculate the potential risk of heart attack based on the historical patient data with number of attributes. So for example, the patient data may have the age, cholesterol value, height, weight, anything else. And then again, you need the input data, create table coronary with age, blood pressure, cholesterol, height, weight. And the last column, heart attack, is level. So it's yes or no. So the historical data, which this record had heart attack, this record didn't have heart attack. Then transform into an array as a vectorized. Just select array, column, column, column. And train the data, build a model. Select star from MADlib log regular function. This is much simpler than k-means. Again, you need to specify which table is input, which column to specify as a feature, as a attributes. Then the built model is like this. So the result is just a record type. So this is just expand as a row. So the feature like age has coefficient negative 9.15. So standard error is here. This is just an example. So I think the value of standard error is very bogus here, but this example shows that the blood pressure has a big impact on the heart attack based on the historical data. And then the classification. So if you have new data without the label, and then you have now the build model, run the logistic function with the dot product with your model, then the result is logistic 7.88 e minus 0.06. Again, this result is, I think it's not valid, but so basically the logistic regression is returns from -1 to 1, and if the result value is positive, then the risk is positive, and if the result value is negative, less than 0, then the risk is negative. So the good part of logistic regression is not just yes or no. It returns the possibility based on the historical data. So how to deploy, how to install the MADlib? Now, I just uploaded the module to PGXN. Right. I mean, so the PGXN client, actually, as of today, PGXN client cannot install MADlib because PGXN client needs a patch that I sent to as a pull request to the author, because the MADlib project needs some configure and make. But PGXN client, as of today, assumes that there is only a make file. But I hope in a few days, they also merge the pull request, and you can just say PGXN install MADlib, then your Postgres is now ready to do this kind of predictive analytics. just for mentioning, we have similar utility tools for Greenplum. So actually, the Greenplum is providing a commutation, Greenplum commutation, which you can use without any money. So you just download the Greenplum binary package from Greenplum's site, and then you can just install it in your Linux, and there's no limitation. So you can run the Greenplum database cluster in your, say, Amazon EC2 in a distributed way and run your analytics with this command. Like to RE, but yeah. Yes, so MADlib is an open source project, and we want you to contribute if you have any insights or new port or for the new method for the machine learning or any good parts, then yeah, we are welcome. Okay. That's it. Oh, sorry. Yes.
So are there any distinctions at all between the way this works or the way it's implemented for Greenplum as opposed to the?
Yeah, so yeah, we carefully designed the compatibility between the Greenplum database and the Postgres. So I think there is no gap feature. Just the modules are parallelized in Greenplum database, but the feature is not different from each other.
So,
Okay, Jeff.
How would you compare this using PLR and some of the functions?
Yeah, good question. So PLR is good for the analytic statistics method, but and actually inside Greenplum we use PLR heavily, but PLR is still not a parallelized way. So it's just run in locally and it runs in memory, right? And the MADlib runs like so writing the data to the database and get back to the calculation. So if the data gets bigger, then PLR may run out of memory.
so parallel query for Postgres. How much would that improve MADlib? And how should people? Is this yet another reason to do parallel query?
In Postgres?
Yeah. Okay.
Yeah, actually, yesterday in the developer meeting, we are talking about how to powerize the Postgres query as a single node. But I think the problem here is a little different from the merge node power query and Postgres power query. So I'm not sure what kind of parallelization, because parallelization is a lot of types of problem. So, for example, it's only, I mean, you can just parallelize the building sort, or if you want to parallelize the aggregate function, then it's a different problem. So I'm not sure what kind of parallelization is going to get into the Postgres. But yeah, if Postgres will have some parallel processing, then MADlib should to consider how to parallelize, how to scale. Yes?
Yeah, are you thinking about adding random forest to this machine learning algorithms?
Sorry?
Random forest?
Random, yes.
Yes?
Yes. For the next B04, we will have random forest based on the decision tree. Yes. Right. Yes?
Couple questions. One, these function calls a block, I'm assuming, while the thing is running. So you call a function and it generates these two tables out there.
Right.
This blocks until it does that.
Yes, so the inside function, it create table, it may create table, a temporary table and some table, but the output is like 2 tables or more than.
I assume you solve concurrency by having static table names. So you call two functions in 2 different sessions, you don't have the same table overwritten.
Okay, yeah. So yes, so we designed this kind of problem, so we're careful to not damage the unexpected result, but yeah, you need to careful. So for example, the decision tree modules create a few tables, but the name is based on the input table. So it just adds some suffix.
Do you generate graphics in any of your function calls, charts?
No, so visualization. Oh, okay. So visualization is our next step. So basically, MADlib doesn't have any visualization tool, but decision tree has some text-based decision tree representation, like explain, analyze. Okay.
So
Yes.
we talked about parallel query a little bit, but were there any other language features that could have facilitated some of the stuff you've done?
Language
Yeah.
feature? Give me.
Were there any language impediments to the types of things that you were trying to implement?
So parallelization here is based on the Greenplum parallelization. So as a language, we don't have any idea to do parallelization in language level.
Maybe I didn't phrase that well. What I meant to say is, so I was wondering if there are any language features or any features in Postgres that could have facilitated the types of things that you wanted to do.
I see.
It seems like maybe it would have been more natural if you had other capabilities in Postgres.
I see. I think that's a good idea to, for example, say, using peer proxy inside the MADlib function, then parallelize the unmodified Postgres, and yeah, we may parallelize the query. Okay. Yeah. Okay, no other questions? So I think that's all. Thank you.